Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 10, Section 3 on types of chemical reactions. So we're going to be going over 4 different types of chemical reactions, and we'll go through a video in class. The first type of reaction we're going to go over is a synthesis reaction. So that's going to be in the form A plus B makes AB. So an element or simpler compound plus an element and or a simple compound makes a compound or a more complex compound. So 2 or more substances combine to form a new compound. So please write that down. And I'm going to have you write down this example, which is an element plus another element to make a compound. So we have cobalt and fluorine will make cobalt fluoride. I would like you to take a moment and balance this equation and then add in your states of matter. And just a reminder on your states of matter, if it's an element, you can look at the periodic table, and then if it's a compound, you should decide, is it an ionic compound or a covalent compound? And if it's an ionic compound, there are 2 options, solid or aqueous. And if there's water involved in the chemical reaction, then it'll be aqueous. And if there is not water involved, then it will be solid. Let's go over a second type of synthesis reaction. In this one, you have a compound reacts with another compound to make a new or more complex compound. So in this case, we have calcium oxide reacts with water to form calcium hydroxide, and I'll want you to take a moment and balance your equation and put in your states of matter. You'll notice that this is a category you'll run into again. I want you to be familiar with. It's a metal oxide reacting with water, which makes a metal hydroxide. So it doesn't have to be calcium, it could be magnesium oxide. That would make magnesium hydroxide. Then the second of the 4 types of reactions we're going to talk about are decomposition reactions. So that's where we have a compound which breaks up into an element, or a more complex compound breaks up into more simple compounds. So please write this down. A single compound undergoes a reaction that produces 2 or more simpler substances. So you know most decomposition reactions need energy, like heat or electricity, to be added for this reaction to occur, which means they are endothermic. You have to put in energy. So if you put in energy in the form of electricity to decompose something, we call that electrolysis. That's the decomposition of a substance when an electric current is added. Let's look at an example. So this is the decomposition of a binary compound. We have a compound which decomposes into an element and another element. For instance, water decomposes into oxygen and hydrogen. Please take a moment and balance this equation and put in your states of matter. I would like to go through another example of a decomposition reaction, which is the decomposition of a metal carbonate. So we have calcium carbonate decomposes into calcium oxide and carbon dioxide. And you can see this was a metal carbonate, and when a metal carbonate decomposes, it forms a metal oxide and carbon dioxide. So for example, if I had sodium carbonate, it would form sodium oxide and carbon dioxide. So please balance this equation and put in your states of matter. Let's look at a third example of a decomposition reaction, which is the decomposition of a metal hydroxide. So iron hydroxide, and we should specify iron 3 hydroxide, decomposes into iron still 3 hydroxide, iron 3 oxide, and water. And we can see this is a metal hydroxide, which decomposes into a metal oxide and then water. So there are some similarities to this one above, where we have a metal oxide, but the other product would be dependent on if it's a carbonate or a hydroxide. So carbon dioxide versus water. So please take a moment and balance your equation and put in your states of matter. Okay, let's look at our third type of chemical reaction. That is a single replacement reaction. So please write this down. It's where you have perhaps an element reacting with a compound, and then you get a different element and then a different compound. So the A boots out the B and makes a new compound. Or maybe you have an element and a compound, but the A replaces the anion and boots that out. So please write this down. A single element or polyatomic ion replaces another element in a compound. Most single replacement reactions occur in aqueous solutions. So often your compound is aqueous. So you want to keep that in mind. Redox reactions are a type of single replacement reactions, and if you remember, we learned about those in Chapter 4. So let's look at an example. Okay, please write this down. Aluminum reacts with iron 2 nitrate to form iron and aluminum nitrate. So it's the replacement of a metal in a compound for a more reactive metal. And please write this down as well. You have metal 1 plus an ionic compound reacts with metal 2, reacts to form metal 2 plus a different ionic compound. So if we look here, aluminum is more reactive than iron, so it boots it out, and then iron will be just a regular element. It's on its own, and then aluminum forms the compound. So please take a minute and balance that equation and put in your states of matter. Remembering that our compounds in single replacement reactions are often aqueous. Let's look at another single replacement example. So sodium plus water reacts to form sodium hydroxide and hydrogen gas. Replacement of water with a metal is another category. So you have a reactive metal reacts with water to form a metal hydroxide and hydrogen. So we'll look here at how this is a single replacement reaction. So we take our sodium and it boots out one of the hydrogens, and we have sodium hydroxide. So it would be NaOH and then hydrogen from one and then hydrogen from the other group together to make H2, because we know H2 is diatomic. So please take a moment and balance your equation and put in your states of matter. Let's look at our fourth and final type of chemical reaction. It is a double replacement reaction. So in here we have AB plus CD yields AD plus CB. So if you see, we flipped. The A and the C flipped places. So you're just switching partners. Please write this down. Two elements or polyatomic ions replace each other in two compounds, making two new compounds. So this often takes place in an aqueous solution. So that's some good hints there. And please write this down. One compound remains aqueous or dissolved in solution, abbreviation for solution, and one compound becomes a precipitate, which is a solid that comes out of solution, or it could become an insoluble gas and dissolve out of the solution, or it could become a molecular compound like water. So please write that down and we'll go through some examples of it. All right, so we have lead 2 nitrate reacts with potassium iodide to form lead 2 iodide and potassium nitrate. So it's going to form a precipitate, and we will, there's a picture of it on page 307, and we see that our 2 ionic compounds switch partners to form 2 different ionic compounds. So the lead kicks out the potassium and it becomes lead iodide, and then the potassium comes over here and makes potassium nitrate. So a precipitate is an insoluble solid. So it comes out of solution. So the solubility rules help predict which compound will form the precipitate. So we talked about one of the compounds stays aqueous and one of the compounds forms a precipitate and comes out of the solution. So we're going to have looking at the book and looking at some rules in our next video, and then also looking at a table, and these are all tools you can use to figure out which one is going to be the precipitate. So some double replacement reactions form a gas. So please write down this equation. So iron 2 sulfide reacts with hydrochloric acid to make hydrogen sulfide and iron 2 chloride. And you'll want to take a moment and balance the equation, and then fill in the states of matter, and you want to figure out, using some logic, which one's going to be the gas. Okay, another example, so please write this down, is magnesium carbonate reacts with hydrochloric acid to form magnesium chloride and water and carbon dioxide. So our category here is metal carbonate plus acid makes an ionic compound plus water plus carbon dioxide. So we could have sodium carbonate and hydrogen fluoride would make sodium fluoride and water and carbon dioxide. So this is just kind of the general category. So please take a moment and balance the equation and go over states of matter. Okay, another important thing to know is that acid-base reactions are double replacement reactions. So they are double replacement reactions, and it's important to be able to identify acid-base reactions. So here are some ways you could identify acid-base reactions. It has an acid. I had you memorize different types of acids, some of the more common types of acids, so that you are able to quickly identify them. Bases, most bases have hydroxide, OH, as it has a metal and then an OH. So you really need to get good at recognizing bases. So acids and bases. So please write this down. HCl, hydrochloric acid plus sodium hydroxide, reacts to form sodium chloride and water. That is a neutralization reaction. And you have your acid plus your base equals a salt and water. So please take a moment and balance your equation and write in your states of matter. And just a quick thing to say about the salt does not have to be sodium chloride. If this was hydrogen fluoride, it would be sodium fluoride. So salts are just part from an acid, an anion from an acid, and a cation from a base. That is a salt, and it will dissolve in water. In our next video, we will talk about solubility rules. I will see you then.